The concept of pixel representation provides an interesting context for you and your students to explore the idea of image representation and how information is stored in general. So in this lesson, we're going to look at how your students can go out on the internet and play with some tools that will explore the idea of pixels. This first example is a simple black and white image where we can see that a 0 represents black and a 1 represents white. So I can create an entire row of black cells by just putting zeros everywhere. I can copy those. So here I'm creating 4 lines of all black, and I'm going to come in and just add a few white blocks in the middle, and if I copy that several times it looks like I have the letter O. So in this way you can see where a series of zeros and ones can represent an image with just binary data. So we can come in the middle here and play with these bits as well and put a little kind of hole in the middle there. So you can also look at the raw format. This is the series of zeros and ones that would be just connected together if this image was streamed across the internet or sent in a message. I can do a readable format. You can see the image width here and the height you can play with. So each bit would represent a certain color across a certain width and height, and we just default to 10 by 10 from where we started. So this next example in stage 2, there's some information that occurs before the actual image, and this is called metadata. So the metadata here represents the width and the height of the image. So this is a 4 by 4 image. I can change this back to a 10 by 10 like we had before by just turning on the 8 and the 2-bit. So 1010 is really 10, and I can make a 10 by 10 again by changing this metadata. So this is just metadata that appears before the actual data, so data about data that's describing the height and width of the image. I can also convert to hexadecimal, where A is 10, so you can see the width and the height there as binary as well as hexadecimal, and you can see the raw format that would be sent across a network or stored on a hard drive or some other representation. In stage 3, there's actually an error in this representation. So code is a little bit off down. You can see here the hexadecimal and binary representation. It's a little bit larger representation. It's a 23 by 23. But here in the bottom left of the C, you can see there's some kind of error there, and some errors in other parts. So the trick here is to encourage your students to try to see if they can find where that error occurs. And the real representation should look like this. So stage 3 should look like this on stage 4. You can also see now we have another part of metadata. So instead of the width and height, we now have width, height, and also the bits per pixel. So this can be used to represent more colors per pixel than just the single 0 and 1 and a binary color. So you can play around with that and have your students just look at what would happen when they play not only with the width and height, but alter the pixel as well. So in this case we have the width, height, and also the bits per pixel. In this case 3 bits per pixel, so we could represent red, green, and blue. So the first bit could be an R, the second bit G, and the third bit a B, so RGB. So we're near the July 4th holiday, so we can make a red, white, and blue matrix here out of the 3 by 3. So I'm first now just converting this to a 3 by 3. You can see how the metadata changes with the actual image width and height. You can see the raw format as well. So I can come in and change this image to be all red would be when the first bit is on, a 1, and the others are off. A white would be all 3, and a blue would be the first 2 off and the third, the B, on. So that first row there you can see. And then if I want to go white, blue, red, alternate that pattern. Then if I wanted to go blue, red, white, you can see the representation of the red, green, and blue. I'm sorry, there, and then I just get white by turning it all on. So I can get the hexadecimal, the binary, and That's just a way to play around with the colors. So stage 6 and stage 7 I won't say a whole lot about. It's very similar here in 6, where you can have the width, height, and pixel and the in bits of pixel data now. You can even save the image. Here in stage 7 we have the icon of the Flappy Bird with different width and height, and now the pixel or bits per pixel is 9, so I can represent over 511 colors with 9-bit pixels. Remember, the traditional red, green, blue we looked at before had 24 pixels, that is 1 byte per each of red, green, and blue. This next one is the final one is very interesting. I have a little bumblebee here that's 50 by 50 in width and height, and the bits per pixel is 12. If you look at this, this is a very large image in binary, so you can scroll through and see that that would be a lot of bits to store and stream. I can also look at it as hexadecimal if I wanted to do that. It's just a larger image compared to the ones we've already seen. Over 2,500 bits in this one, or actual, I'm sorry, 2,500 pixels in here, and then we're storing 12 or more bits per pixel. So as you start to change in bits per pixel, something really interesting happens when I go double from 12 to 24. I get 2 images at different colors. So one thing you may want to do is think about that in terms of the overall representation of this image, and encourage your students to explore around and see if they can actually find what happens here and be able to explain this phenomena. So this is a really interesting tool that Code.org has provided, and it allows you to have a way that your students can understand how images are represented, understand the concepts of metadata, and be able to just explore those concepts in a self-contained tool. So give that a try and spend some time with this, and think of ways that you might introduce this to your own students.